Here we go, folks, looking at problem 15, the last one in the multiple choice section. It says a machine is rolling a metal cylinder under pressure. The radius of the cylinder is decreasing at a constant rate of 0.05 inches per second, and the volume is 128 pi cubic inches. At what rate is the length of the height changing when the radius is 1.8 inches? So the first thing we're going to do is we're going to write our acronym RIPDISC here. So we're going to read, identify, we're going to draw a picture, we're going to get an equation, and then we're going to differentiate with respect to time, and then we're going to solve. Okay? So we read it. So now that we've read it, we're going to identify our variables, our relevant variables here. So it says a cylinder over here. So we know what a cylinder is. It's basically like a Coke can, if you will, right? Under pressure. The radius of the cylinder is decreasing here. So at a constant rate. So it's d something, or ddt of something, and it's a radius, so drdt is negative 0.05. It's negative because it is decreasing. The volume is 128 cubic inches, so that's V is 128 inches, or pi inches cubed. And notice, it's not like a rate, it's just a volume. And it says here, at what rate is the length? So at what rate is the length of the height changing? So I want the rate, so this is d dt, right, of the length of the height. So the height is changing, so that's dh dt. So I want to find that, and when my radius is 1.8, so that means r is 1.8 inches. Okay, so I've identified a few things here. I know so far that drdt, let me write it a little bit more clean, is negative 0.05, right? I know that v is 128 pi. I know that r is 1.8 inches. And I'm trying to find dh dt. Okay, so now I need a picture. What's going on here? And this kind of makes sense if you think about it. What we basically have here is, like, if you guys ever had like Play-Doh? When you have Play-Doh here, and you know when you have it on like a flat surface or whatever, right? And you roll it with your hand, and it starts to elongate, right? So it starts to stretch out that way. But if you notice, as you roll it, the radius, or excuse me, the thickness of it starts to decrease as well. That's basically what's happening here. Is you're just rolling this thing, and the height is increasing, and the radius is decreasing here. And that's what we're trying to find here, basically. So because we have V, it's volume, so we know the volume of a cylinder is just pi r squared times h, okay? So here is our equation. So we've read, we have identified, we've got our picture, equation done. Now we're going to differentiate with respect to time, and then we're going to solve, okay? So I'm going to use my equation. So V equals pi r squared times h here. And I'm going to go ahead and plug it. All right, I'm going to differentiate. So ddt is, so ddt of V is dv dt equals, pi goes along for the ride, so because it's times ddt of r squared times h. And if you notice here, you have to think, so can I plug any of stuff in for r and h? We have to think, which one is changing? Is r changing or is h changing? You can only plug something in if they're not changing. And if you think about it, the height is getting longer and r is getting smaller, so they're both changing. So you can't plug in. So no plugging in now. No plugging in at this moment. Okay? But what we can do is we can differentiate them, and we're going to use the product rule. So dv dt is pi times the derivative of the first, 2r times dr dt, times the second, plus derivative of the second, which is dh dt times the first. Okay? Now, we have this equation here, and now we're going to plug in what we know. What do we know? Well, we know here that the volume is this here. And this is an interesting idea here, because when we have dv dt, this is how the volume is changing, right? And if you think about it, does this volume change? Well, changing, it means it either increases or decreases. It can't really increase or decrease, because it's not like you're cutting it up. You're just making it a different shape. So the volume is not changing, right? So this dv dt is 0. It's not changing, right? Another way to think about it is at this stage here, you could have, if you wanted to, you could have plugged in 128 pi into v here. So if you plug in 128 pi, and if you took the derivative of a constant, you would have gotten 0. So dv dt is 0, both algebraically and conceptually. And now we just continue to solve. We know r is 1.8. That was given in the problem. R was 1.8 inches here. So 2 times 1.8 times dr dt is, where is it? There we go. Negative 0.05. There's the dr dt. I'm just plugging this stuff in here. Times negative 0.05 times h. So this h may be an issue because h was not given anywhere. Not directly anyways. So how would we find h? Well, I know, so you're going to use your equation that we used, and we're going to use this one here. And we know that v was 128 pi, and that is pi. R was, what was it? R was 1.8 squared times h. So we can use this to solve for h here. Before I use a calculator, let's cancel the pi's. So we know that this gives me that 128 equals 1.8 squared times h, right? Let's go ahead and square out this on 1.8 squared. That's 3.24. So I get 128 equals 3.24h. I divide by 3.24. And h is 128 over that, which is a 128 divided by 3. And that's going to be this guy here. So the height is approximately 39 point, looks like it was what? Like 5.6, right? We're going to plug this in for h. Oh, sorry. In for h here, right? So times h, which was 39.506 plus dh dt. I can't write either. That's okay. And dh dt wasn't really given either, was it? Oh no, that's what we're trying to find. Duh. Haha. God, I was really confused. I was worried there for a second. Times dr dt. There's really no room for this one. I'm going to just rewrite this again. Okay. So 0 equals pi times 2 times 1.8 times negative 0.05 times 39.506 plus dh dt times what? R squared. R squared is 1.8 squared. And now we simplify, and all that times pi. And we simplify this, and oh, this is a monster, huh? It's kind of annoying. So we're gonna go. I'm gonna distribute pi, so it's 2 pi times 1.8 times negative 0.05 times 39.056. This is equal to 0 plus dh dt times 1.8 squared. And now at this stage, I'm just going to use a calculator and just get a number for this. So I'm going to go check it. I'm going to go 2 times pi is second caret. What was it? Times 1.8 times negative 0.05 times 39.60506. And this whole mess is negative 22.34 plus dh dt times 1.8 squared, which was 3.24, right? And so I'm going to have, this is equal to 0. What I'm going to do is I'm going to add 22.34 to this side. So we're going to get 22.34 equals 3.24 times dh dt. We're going to divide by 3.24 to both sides. And hopefully this will give us the answer here. Because if we're wrong, man, I don't know. This is kind of depressing, right? So I already have this in my calculator. And I'm just going to divide this by 3.24. And, it's going to be the positive of that. And so, looks like my answer is none of these, based off of this one here. So, I'm not sure about this one. This seemed like a lot of stuff. I'm kind of tired, so maybe I made a mistake. I went kind of slow, too. But the goal for us is to kind of go through the process with this, okay? I did not reach or attain an answer here. So it looks like on the outset the answer is E, none of these, although I was hoping that it would not have been E. So let's go ahead and see how you do with this one. Here, try doing it by yourself and see if you can extract the same result. Double check my work, make sure I didn't mess up anywhere, okay?